So now you are working which project? Now you are working which company?
Sorry,
Now,
Riga Technical.
yeah, technical.
Riga Technical University. Only one in Poland.
Here only. Okay.
It's enough.
It's okay because mentally you are working power plant or mother sector also.
No, I'm employed full time.
Full time here. Okay. Nice.
I'm not saying what I participate in other projects, but
okay. So now you are doing which project, sir?
at this moment,
Okay.
only here.
Only
But
you are not doing any project or any research kind of things.
There will be in future.
Okay.
But at this moment, I'm here.
Okay. Okay. Done.
Not to forget to fill attendance.
Just name and surname. Any title. All the department code from. Okay. Name and surname without. Password I already just the surname. In the past year, modules also we have created and what is also known as subject view for students. Then schedule. Okay, that is exactly then you wait for few seconds. You will got to
What I'm going wrong.
maybe now it's not working. It's working in my mobile. Bluetooth. Okay. So only display. Okay. You don't have this one? No, why? Maybe you got no source. This is these classes are this are free. So
Attendance 1, 2, 3. Attendance.
yeah.
We have Harry Kumar Anu, Kumar Sailesh, and Rachinadrin Arvindan.
Yes. No.
Sorry for misspelling.
No problem. I got RP card, so I don't need to apply because I already did not the engineering.
Okay, this one is filled. This one is okay. This one is okay. Here we're fine. Not needed. I should save this. Okay, let's go forward. Let's go forward, and what do we see? We see a network. Good network, but we need a contour matrix here. Yeah? Let's continue to our network. A, B, contour and branch are in green. 2, 3, 4 and 5. Matrix of contours, and also known as B and P transposed. Matrix. Do you like matrix? Because matrix likes you. B. Co-directed plus 1. Counter-directed minus 1. So, can we feel it? Where is the number 1? What can we tell about first contour? A. Co-directed or counter? What should I write? Plus 1 or minus 1?
Minus is 0.
Branch go. Why 0?
Other than that,
A contour. Branch. Why 0? So, idea. Plus 1, minus 1, 0. What should I write? Imaginary guy walks this way.
0. Plus 1. Here minus 1 equal to 0.
A minus 1 because against the walk around direction. And for B, in direction. 1. For the number 2, A contour, no connection, 0. B contour, what should I write? Minus 1, negative. Number 3, A contour, 1, B, no connection. Where is number 4? You, the number 4. What's with number 4? A contour, 1 and 0. And number 5, B contour, 1. Here it is. Second incidence matrix or contour branch connection matrix. Now I can do something about Kirchhoff voltage law. What will be voltage drop? Voltage drop, current multiplied by resistance. I should not draw this. Like this. For example, we have a water reservoir. Water flows. Water level is equivalent for voltage, yeah? flow is equivalent for current. And cross section of the pipe is resistance. So current, yeah? Yeah. Now voltage drop. One component. I can put voltmeter here and here and here and here. This will be voltage drops, yeah?
Zero, yes.
And some should wait with zero. We have two components. One current multiplied by resistance and second from EMF, yeah?
Yeah.
Yeah. That's me. What? N L E V. Voltage drops from current on resistance minus N. N gives me connection to branch equals to 0. What is it?
Maybe it's not equal to
What I have written? Sum of voltage drops on any closed contact equals to 0. This is Kirchhoff voltage law. Or in more, equals to N. VE branch. If EMF is in branch direction, it will be plus. If EMF is against the branch direction, minus E. Second, Kirchhoff's law or Kirchhoff voltage law. Contacts as branch to contacts, resistance, matrix, current. Resistance matrix, branch, resistance of the first branch, resistance of the second branch, of the third, and so on. In our case, how it will look? I should feel it. So, first, second, third, 4 and 5th. 1, 2, 3, 4, 5. Resistance matrix. 1, 1 position. What should I write?
1, 1.
1, 1.
1 and it's 1. Okay.
2, 2.
2,
3, 3.
R,
Resistance of the third branch. 4, where are you? It's number 1. And this is number 5. All other positions are zeros. They will not, we will fill them in AC networks with mutual inductance, if they will be any. Here is resistance matrix. EMF matrix is very simple. Everything here is very simple. First, second, third, fourth, fifth. EMF factor. First branch, an EMF, no. 0. Second. What about second? 0. Third. 0. Number 4, E1 in direction. And number 3, minus. Here it is. Nothing to think about. Nothing to worry about. Very simple. As you can see, it's very, let's say, technological. It's like on conveyor. Analyzes. Really, I analyze the let's say decompose or first into sequence of very simple operations. Now what can I write? I can again write two things. And M F equals by NA. What is this? KCl, KBL. Pair of Kirchhoff's law. I can conduct them into one nice actuation system. Equals to I and A. It's a combination of Kirchhoff laws. This is what's this? It's called often system or circuit state system. With this system, I can solve network and find branch current. Good news. Bad news. It takes me as much work as possible. First and second, I don't want to do anything by hand. I want everything done automatically. But conduction of contour matrix isn't an easy job for machine. I would like to use something more comfortable. What can I do? I can start from Kirchhoff current law. What it tells me? Clean my blackboard. sum of current in any node equals to 0. Let's say I have some network. This is node 1. Let's say this is node 2, this is node 3. Okay, this is base node. Connection, not important. Node 1. For example, why for example? Why for example? Physics introduce idea of potential. Yeah, this one to 0. Base node, let's say, is 0. This one has potential 1. And third node, potential of the third node. What will be current? What will be current, Kirchhoff's current law for the first node?
The current positive.
1 minus phi base divided by R1 base plus 1 minus phi2 divided by R1 2. Yeah? Between and plus potential of the 1 divided by L1 to 3 equals to what? Okay, let it be a current source. Equals to current source. Nice? From the physics point of view. To make things look a bit better, I can replace or substitute resistance with conductivities. So, conductivity, let's say 1, 3 is 1 against resistance 1, 3. And also I can conduct all members together. So I will get something like 1 multiplied by conductance 1 base plus conductance 1, 2 plus conductance 1, 3 minus Phi2 conductance 1, 2 minus Phi3 conductance 1, 3 equals to nice? Nice. I can do it for all nodes and I will get something like this. Conductivity matrix multiplied by potential vector equals by nodal current. I have no, at this moment, I have no EMF. I started from the simple network without EMF. This conductance matrix has a structure like this. II is a sum from starting to 1 to number of nodes of conductivity I plus conductivity I base. Sum of all branch conductivities. For 1, 1, all branch at the first node. 2, 2, these two branches. 3, 3, all branches connected to node number 3. So at the diagram we have sum of all conductivities. Other elements I excluding I equals R minus conductivity between I and between nodes I and G. 1, 2, first, second. 1, 3, this one. 2, 3, this one. 0 if no direct connection. We will have nice equation system, but this system lacks EMFs. If, let's say, some branch has, we will introduce some E, I don't know, with some number. What we can assume? We can assume that this EMF will produce its own current. We can assume system linearity, meaning that superposition idea is applicable. Have you ever heard about superposition idea? No?
Yes.
Or technique, superposition technique.
Yes. Superposition technique. Yes.
Yeah. So idea what we can assume real regime as a sum or superposition of partial regime. What's the key covenant for superposition idea? System must be linear. Resistance must be constant, or nothing good can happen. If resistance are constant, we can assume what? Current from potential difference minus currents from EMF source. What each EMF source produces its own currents are equal to current source, or equals to this tells what E is like first Kirchhoff, when each current, each voltage source, each EMF divided by branch resistance produces its own current. This is nodal potential technique. We use more advanced technique of nodal voltage. Techniques of nodal voltage works not with potential but with voltage. Base voltage should be constant, and we will have here voltage, voltage and voltage. In case of voltage, our equation will look like nodal admittance matrix, voltage, nodal voltages. What will show voltman? Between ground and node. Not between base node and ground, but and node, but between ground and node, equals to current sources minus current from EMF source plus no vector of admittance or conductivities between nodes and base node. This one is for current from the base node. E times is a conductivity between node E and base node. We should not conduct it. It can be easily calculated because equals to sum 1 to number of nodes of conductivity nodal admittance matrix elements for each I from 1 to number of nodes. It is easy. This equation system called nodal voltage equation system on method of nodal admittance matrix is the best for our business, in my opinion. This equation system in general, first Kirchhoff current law, but it contains less equation than the full system and do not require for me to conduct contour matrix. But how can I get nodal admittance matrix? I need nodal admittance matrix. Where is my... Where is my board? Dang. This is good. Dang. Couple. Before speaking of this matrix, before speaking of this matrix, one tiny remark. When we spoke on Kirchhoff voltage law, we can, what we can do? We can tell about voltage drops. Voltage drops on the branch. R, E. it's voltage drops. B branch currents.
Okay.
It's a vector of branch currents. Voltage drop.
But E
From
source, right?
it's a branch current resistance and EMF vector. We can write like second Kirchhoff voltage law and multiplication of branch resistance by branch current is a voltage, this voltage drop. But what do we see here? Ohm's law. It's a Ohm's law. But
Yes,
volt,
it's a Ohm's law, yes.
yeah, it's a Ohm's law. But from the other side, if we solve our system equals to n plus, what shall we get? Nodal voltages. And delta U is a difference between node voltage. If, for example, we have node 1, node 2, this voltmeter between two will show us this element of this voltage drop on the other hand. Yeah? Yeah. And delta U can be found as transposed M matrix because why transposed? Because we need difference.
Difference, okay.
These two are equal in reality. What this means? What L E branch equals to
M trans.
E minus M transpose minus from here
Yes.
I can write what branch currents are inversion of resistance matrix why here should be plus. Yeah, here should be plus. It will be E plus M transposed minus base. This gives me a branch current from the voltages by the Ohm law. But that's not all. I can also use what? Since I have a second Kirchhoff, L E minus equals to 0, I can component width delta U equals M transposed this one equals to this.
Sir, here what is M?
Uh,
What is M transpose? Yes.
M, first incidence matrix.
Oh, okay.
And T means what is transposed matrix? Oh yeah. If I have matrix A with elements IO, its transposition will be rows
Column.
with column. Like rotating 90 degrees. What I am feeling to write. And M transpose B should be 0. If we assume E is 0 for a moment, all voltage drop will come from current sources, but we don't have any current sources here. This means that in any case, M multiplied by M transpose or M multiplied by M transpose should yield 0. It's a good instrument to check what you have conducted matrix correctly.
What is N?
What? N?
N.
This one.
Yeah.
Matrix of contours branch. We just conducted it. Second incidence matrix. Where should we be? It's a good instrument to check what matrices are conducted correctly. But I should go. Where should I go? I should go to the way to get my nodal admittance matrix. I need nodal admittance matrix. I don't want to conduct it by hand. Nodal admittance matrix. Not this. Yeah, plus. Let's assume we have a small schematic with EMF 0, not 0, powered only by current sources. So, GAU will be I, and branch currents will become R inverse, M transposed, voltages. I can substitute, what can I do? I can, I knew what M E branch equals by I because of the first Kirchhoff law. Okay. And this one will become M I but I knew this, meaning what I can write like this equals to M R inverse M transpose. and voltage. I got what I need. I have a way to get nodal admittance matrix like first incidence matrix, inverted resistance matrix, 1/4 equivalent, okay, and transposed matrix. I got what I am looking for. So I can solve problem of DC network like M inverse M transposed U equals to I plus base node conductivity, base node voltage. This will be linear equation system from the classical math. In general, it's a bingo. If I conduct contour matrix by hand, what can I use? Also, method of contour currents. Do you know it? Contour currents. With idea what each independent contour has its own current. I will have equation system like contour resistance, contour current equals to set of contour EMFs. This one is easy. And the problem I can base my solution on a second Kirchhoff law, on a Kirchhoff voltage law, assuming that each contour has its own current. But where is my super 1 second. I'm not trusting a problem with an EMF conduction for the second Kirchhoff law. If I would like to use a second Kirchhoff law, I need to collect voltage drops. But I need, if I'm willing, let's say, use only second Kirchhoff law, I will have problem. Because I need to account both real EMF and voltage drops from current sources. For this one, everything is easy. It will be component and as for second Kirchhoff law. But what should I do with current sources? Very specific idea. And idea is I need, let's say I have a current source attached like this. I need somehow to account energy supplied by this source. What idea? I will set an artificial path for this current. I will simple assume how can I direct it? What it flows like this. I can assume such flow and conduct a special matrix in such way if this artificial current from current source flows in direction of my branch, I should write a value of current source with a plus. If flows in opposite in counter direction, I should write it with a minus sign. This allows me to introduce energy from current source into second Kirchhoff law. And I can get contour. It's imaginable. It's not a real EMF. It's a kind of equivalence. Like so I need to solve now a system N transpose equals to N minus F. This is second Kirchhoff or Kirchhoff voltage law written for artificial network. It's a some derivative of my network, assuming that in each independent contour flows its own independent current. It's also a linear equation system. It can be solved without any problem as any normal linear equation system. Only problem, real branch currents. I need to take this back. So it will be transposed plus J. This will give me real branch current. With voltages, it's not so easy, but you can get it. It will be M multiplied by M transpose inverse E branch minus E. This will give you a voltages from contour current. Key advantage of this technique, it requires minimal number of equations. But key disadvantage, automatic conduction of contour matrix isn't easy task. You need to first separate a tree, find this independent branch chords, so on. It's a work. But conduction, automatic conduction of you need to find a path along the graph. It will eat your, any performance. So if you do your calculus by hand, if you conduct matrix by hand, this is okay. In reality, it takes, if you conduct matrix by hand and calculate also by some basic machinery, this is the best. If you do it, machine do it, you only program, no. This will not yield performance. Okay, I think it's enough for today. People are starting to fall. Next time we will solve a DC network. Next time I'll show how to solve a.
Sir, which software you are using to analyze them is?
I prefer today Scylla because it's free. Okay. Actually, this will work with any environment. You just need to be able to define array and perform basic math operation on complex number.
Okay.
So in general, any environment can work. Why I'm preferring Scylla? It's free for students. C-Web. Yeah. Cweb.org. It has all necessary math functions. SCI, scientific web. SCI-web.org. Scylla, scientific.
Okay. Cweb.org. Okay.
It found?
Yes, I found.
Yeah. It's free for students and has enough mass we need.
Okay.
Yeah. You can, I use 6.11.
Okay.
Previous version. It's faster, but no problem. You can actually you can use any version.
Okay.
Fifth series also worked fine. I checked.
Okay, this is a free version.
Yeah, it's
Okay.
absolutely free. If you're familiar with MATLAB, also okay. In previous year, one guy was very prolific in C++, used C++.
Okay.
Right, much more work, but
Okay.
mascot also can be used, but it's a bit strange. Okay, I think it's enough for today. Next time we will solve a network.